Check one. Check one. Right. Good evening, everybody. Back again with our online session, the night MCQ program. By now, we have finished 100 MCQs. Today, we'll have to go ahead with our 110th MCQ. That is 2021 O-level paper. That is 2021 O-level paper. Question number 21 to 30. Third set of MCQ. Right? Before we start, confirm me from your end, is all the dues perfect? Good. Perfect. YouTube. YouTube, okay? All right. All right. Uh, so today we'll have to go ahead with question 21 to 30. I will start the session. While I'm doing the session, I'll talk to you all. Right. Before we start, y'all, get ready with your review book. Now we all know what title. Ready. Ready with the review book? Yes. Ready. Ready. Absolutely ready. Hurry. Right. We'll start the session. Now, this set of paper, this set of questions in the paper, resistor question, there are two. Resistor यानी current electricity part, there are two questions. This one, there is something for us to discuss. Right? This is, even though they have given a big diagram here, even though they have given graph-like question, it's not actually a graph-like question. If you look at the question deeply there, other than that, this one, there is a small logical question. Question number 29. A small logical part is there. Those are the main questions we'll have to discuss. However, I'll go in the normal order today because most of the question there is something to discuss. So I'll go in the normal order. So we'll start from question 21 until the 30th question. Normal order will be going today. Right. Question 21 of 2021 O-level paper. So today you are happy. Why, Puta? I should not be happy. That also comes as a comment. Question 21. Right. Go to the question. A few ways of connecting four resistors of equal magnitude are shown below. Of them, which one has the lowest equivalent resistance? Four resistors of equal magnitude are connected in different ways. They are connected in different ways. They are asking in which one the lowest equivalent resistance is there. The connections are four resistors in series, this kind of a resistor combination, this kind of resistor combination, four resistors in parallel. Those are the connections. We will do like this. Now, in this question, values are not written. They have not given any value. What they are telling is a few ways of connecting resistors of equal magnitude. Only resistors of equal magnitude is given. They have not told the magnitude. And they are asking us to find the lowest equivalent resistance. In such a question, what you can do is, if it is hard for you to logically analyze, today I'll tell you how to logically analyze as well. If it is hard for you to logically analyze, put some values and calculate and see. Put some values, calculate and see. Now, for example, we'll just write 2 ohm. Each resistor is 2 ohm. Annaputi, you all tell me. Series connection, nothing to calculate. One resistor 2 ohm now. I'm just telling it is 2 ohm. If you don't like 2 ohm, you put 3 ohm there. If one resistor is 2 ohm, four resistors in series, you add all the four together. What's the equivalent resistance? What's the equivalent resistance? One is 2 ohm now altogether. Perfect. 8 ohm. I will write it in the white the board there. So first connection, our equivalent resistance is 8 ohm. Second connection. Look at the second connection. There is a parallel connection. There are two resistors in series connection. There is a parallel connection, two resistors in series connection. This is our connection. I'll give 2 ohm for each resistor. I'll give 2 ohm for each resistor. They are telling no equal value resistors are connected. So each one 2 ohm. Now those who are with me from the beginning of this session, I have taught you all a shortcut for two resistors in parallel. For two resistors in parallel, I have taught you all a shortcut to calculate the equivalent resistance. Can remember. What's the shortcut to calculate the equivalent resistance when there are two resistors in parallel? Those are new, listen. If there are two resistors in parallel, you can easily find equivalent resistance by multiplying the two values, and dividing that value by addition of the two values. 2 and 2, multiply it, 2 into 2, divided by 2 plus 2, add it. Multiplication divided by addition. Now do the math there. 2 into 2, 4. 2 plus 2, 4. That is 4 divided by 4, 1 ohm. Which basically tells us these two resistors will give us a 1 ohm equivalent resistance. These two resistors, 1 ohm. Now add all of them together. 2 ohm plus 1 ohm plus another 2 ohm. Altogether, what's the equivalent resistance? 2 plus 1 plus 2, altogether how much? 5 ohm. So your second connection, equivalent resistance is 5 ohm. So do they have to be equal for the method you taught? No, there is nothing like that. Let it be 2 and 3. You can multiply, divide by addition, you will directly get the equivalent resistors. Only one condition, if you are using this shortcut lamai, you can only use it for 2 resistors in parallel. 3 resistors in parallel, 4 resistors in parallel, you can't use this shortcut. Only for 2 resistors in parallel, you can use this shortcut. So shortcut is multiplication divided by addition will give us the equivalent resistance. That is 1 ohm plus 2 plus 2, 4, altogether 5. The second connection, equivalent resistance is 5 ohm. Third connection. One resistor like that, 3 resistor in parallel. Third question, one resistor like that, 3 resistors in parallel. Again, we'll put the value 2 ohm, 2 ohm, 2 ohm, 2 ohm. Now 3 resistors in parallel. You can't use the shortcut. Shortcut is only for 2 resistors in parallel. 3 resistors in parallel, you should separately find the equivalent resistance. How to find the equivalent resistance in parallel connection? 1 equivalent resistance equal to 1 over 2 plus 1 over 2 plus 1 over 2. Reciprocal of equivalent resistance is equal to addition of the reciprocal of each resistors. Half plus half plus half. How much? 3 over 2. Need 3 over 2. Remember, this is 1 over Req. If you want Req, what you need to do? You need to turn the final answer upside down. This is 1 over Req. If you want Req, you need to turn the final answer upside down. So if I turn the final answer upside down, that is 2 over 3. 2 over 3 is 0.67. So this parallel connection, my equivalent resistance is 0.67 ohm. Now this is 0.67, this is 2 ohm. Altogether how much? Altogether how much? Hmm. 2.67. So altogether you get 0.67. So this connection, your Req is 2.67. How about the last one? 4 resistors in parallel. 4 resistors in parallel. 4 resistors in parallel. Fourth one, 2 ohm, 2 ohm, 2 ohm, 2 ohm. Each resistor 2 ohm. 4 resistors in parallel. Each resistor is 2 ohm. Now here you can't use the shortcut. You should go with the normal method. Here you can't use the shortcut. You should go with the normal method. 1 over Req is equal to 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2. 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2 is 1 over 2 into 4. Agree? Agree with my calculation? 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2 is 1 over 2 into 4. Now again, cut it, no? 2. So from there, 1 over equivalent resistance is 2 ohm. This and this cancel off, you get 2. Remember, this is 1 over Req. You don't need 1 over Req. What you need is Req. Take the reciprocal. Req is equal to, you turn this one upside down. Then you should turn the other one also upside down. Half. Half is 0.5 ohm. Half is 0.5 ohm. So now compare all of them. I'll write the overall resistances. First one, 8 ohm. Second connection, 5 ohm. Third connection, 2.67 ohm. fourth connection, 0.5 ohm. Which one has the lowest resistance? Which one has the lowest equivalent resistance? Fourth one. Fourth one has the lowest equivalent resistance. So your answer is answer 4. Answer is answer 4. Now listen, eh? Now listen, the most important part. Remember, in series connection, always the resistance value will increase. 2 plus 2 plus 2 plus 2, we got 8 ohm. Resistance value increases. Series connection, the resistance value will increase. In parallel connection, the overall resistance, equivalent resistance will decrease. The more you have parallel connection, the more the equivalent resistance will decrease. See, with that logic, you can easily compare. Series connection equivalent resistance increases. Parallel connection equivalent resistance decreases. The more parallel connection, the more it decreases. See, now see, no need to put values. See, this is fully series connection. This circuit, fully series connection, full and full series connection. Here, two resistors in series. Here, all the four are in series. Here, two resistors in series, another two parallel, that is connected to that. That is connected to that. And two directly in series, that is connected to that. Look at here. One resistor in series, other three are in parallel. One resistor in series. Here, all four are parallel. Four resistor in series, highest equivalent resistance. All four in parallel, lowest equivalent resistance. If you compare this and this, two are in series, equivalent resistance is somewhat high. Only one resistor in series, equivalent resistance is somewhat low. Check the values and see. Isn't it coming in that order? First one highest, second one second highest, third one third highest, fourth one the lowest. Check. Check whether our values are satisfying. First one 8 ohm, highest. Second one 5 ohm, second highest. Third one 2.67 ohm, third highest. Fourth one lowest. So 1 second you can do the question, isn't it? The same question without applying any values, within 1 second you can do the question. You check where the most number of parallel connection is there, and right, that's the lowest. Now let's take, in your batch, they're asking a question like this. Which connection has the highest resistance? Which one? First one. No need to sit and calculate in it. So keep that in mind. Some people ask me about the shortcut. Shortcut, I think I taught in the first paper. But as y'all asked, I will again teach that shortcut thing. Shortcut is ලොකු දෙයක් නෙවෙයි. Let's take, there are two resistors in parallel. Only for two resistors parallel, you can apply the shortcut. Only for two resistors parallel. And that also for MCQ question. Let's take two resistors are there in parallel. One is 4 ohm, one is 6 ohm. You don't need to put that 1 over Q, find the reciprocal, convert it to the other side. All those things you don't need to do. You can directly find equivalent resistance. How? You multiply the values of both the resistors. 6 into 4. And divide it by addition of the values of two resistors. 6 plus 4. Multiplication divided by addition. You multiply, divide it by the addition. So if I do the math there, 6 into 4, 24. 6 plus 4, 10. 24 divided by 10, you directly get your R equivalent. Reciprocal story is not there. Directly you get your R equivalent, 2.4 ohm. If you want, you do it in normal method and see, you will get the same answer. Do it in this method and see, 1 over R eq method. You get the same answer. Right? So that's a shortcut. That's shortcut. Multiplication divided by addition. Okay. So your answer for this one is answer number 4. Right. Question number 22. Consider the following organs. Okay, we will consider skin, kidney, pancreas. Of these, those that contribute to maintain homeostasis of the body is. What is homeostasis means? Maintaining a constant internal environment. Homeostasis means maintaining a constant internal environment. What are the things that has to be maintained by homeostasis? What are the things that has to be maintained by homeostasis? What are the things that has to be maintained constant in your body? Number one, your body temperature. Your body temperature should be maintained at a constant level or at a very narrow range. Number two, your blood glucose level. Your blood glucose level should be maintained at a very narrow range. Number three, water balance. Amount of water in your body should be maintained. How are these things maintained? They are maintained by some hormones plus some responses that are done by our body. Hormones and responses that are done by our body. Now, if you take the body temperature, how is the body temperature maintained? Let's take it's very hot outside. What will your skin send out? What will come out of your skin? When it's very hot outside, when it's very warm outside, what is going to come out? Sweat. Sweat will come out. So basically, our skin will help us to maintain the body temperature. Blood glucose level. If your blood glucose level is high, what hormone is secreted? When your blood glucose level is high, what hormone is secreted? Insulin. Who secretes insulin? What is the gland that secretes insulin? Pancreas. So blood glucose, when the level is high, pancreas will secrete insulin. Water balance. If you drink a lot of water, what will our kidney do? Excretion is happening. So kidney will help there. Basically, ADH hormone will go and act on the kidney. Kidney will increase or decrease the reabsorption. Kidney will increase or decrease the reabsorption. So basically, these are the organs that help us to maintain these three things. Now the question is asking, consider the following organs. Of these, those that contribute to maintain homeostasis. Tell me, what's the answer? What contribute to maintain homeostasis? Skin help us to maintain the body temperature. Kidney help us to maintain the water balance. Pancreas help us to maintain the blood glucose level. Then all the three is what? Answer 4. All the three, answer 4. There you go. All three, answer 4. Okay, simple questions. Next, the graph P and Q respectively indicates how the body temperature of two organisms P and Q varies with the temperature of the environment. Organism P and Q respectively can be. Look at the graph now. Some people are very scared when they get any graph like question. First, look at the graph, analyze the graph. Look at the graph and analyze the graph, what the graph is telling. Look at organism Q. Look at organism Q. Can you see when the environmental temperature increase? When the environmental temperature increase, when environmental temperature is increasing, body temperature of Q is also increasing. Can you see? Environmental temperature is increasing, body temperature is also increasing. Can you see that in the graph? That is what you mean by constant gradient graph. No? When increases, y is also increasing. That's the meaning. So in this graph, when the environmental temperature increases, body temperature also increasing. That means body temperature is changing with the environmental temperature. For organism Q, body temperature is increasing with the environmental temperature. It's changing with the environmental temperature. Is it having a constant body temperature? No. Body temperature is changing. But look at P. Environmental temperature is changing for P. But is the body temperature changing? Is it increasing? Is it decreasing? Is there any change there? No. No changes. Environmental temperature is changing, but body temperature is not changing. You call that as what-blooded? You call that as what-blooded? Constant body temperature. What-blooded? Warm-blooded. Warm-blooded. So guaranteed P is warm-blooded. Warm-blooded. Guaranteed P is warm-blooded. What about Q? Q's body temperature is changing with the environmental temperature. Q's body temperature changing with environmental temperature. You call it what-blooded? Cold-blooded. If body temperature changes with the environmental temperature, you call it cold-blooded. So guaranteed Q is cold-blooded. Now the question is, what is going to be warm-blooded? What is going to be cold-blooded? Memorize and keep aves and mammals. Both of them are warm-blooded. Both of them are warm-blooded. All the others are cold-blooded. Only two are warm-blooded, aves and mammals. All the others are cold-blooded. Okay. So guaranteed P is what? P is echo aves, not the mammal. Then something else. Something else is going to be cold-blooded. Something else is going to be cold-blooded. They can be pisces, fish, or they can be amphibia, or they can be reptiles, reptilia. Other than those three, the last two, aves and mammals, are warm-blooded. So going back to the diagram, graph P and Q respectively indicate how the body temperature of two organisms P and Q varies with temperature of the environment. The organism P and Q respectively, P is guaranteed aves, P is guaranteed aves or mammals, Q is guaranteed pisces, amphibia or reptilia. Now check the answer. Ox and bat. Ox and bat. What can you tell about ox and bat? Both are warm-blooded. Remember, bat is warm-blooded. Ox is warm-blooded. Both are warm-blooded. Both are mammals. Both are, ma'am. Both are warm blooded. We don't want both more warm blooded. We want one. The first one should be warm blooded. Second one should be cold blooded. Both are mammals. Both are warm blooded. Fowl and tortoise. What can you tell? A bird is there. Reptile is there. Birds are warm blooded. Reptiles are cold blooded. Yes, it can be an answer. It can be an answer. Second one can be answered. Third one, elephant and duck. Elephant and duck. Both are warm blooded. Frog and tilapia. Frog is amphibian. Tilapia is a fish. Fishes. Both are cold blooded. So answer is answer one. So don't go to think a lot when they give a graph. First analyze the graph. What is the x-axis telling? What is the y-axis telling? How the graph is working. That's it. Once when you analyze that, you get the answer. Onnabute. Question 24. Question 24. In which order does the brightness of the bulb decrease in the circuit A, B, and C? In which order brightness is going to decrease? Decrease can highest brightness to lowest brightness. We'll compare the circuits. First circuit, power supply is there, bulb is there directly. Second circuit, power supply, resistor, bulb, resistor in series with the bulb. Third connection, power supply, bulb is there. In between, can you see there is a wire? That means they are basically short circuited this. They are basically short circuited this. Right. Now, this brightness of bulb question. How to solve that? Remember, brightness of bulb. Brightness of bulb is very important. Brightness of bulb. Brightness of bulb, I'll name it as B. Brightness of bulb increases when the resistance decreases and when the potential difference increases. Lesser the resistance, greater the brightness. Greater the potential difference, greater the brightness. So you decrease the resistance, you can increase the brightness. You increase the potential difference, you can increase the brightness. Vice versa. Brightness decreases when the resistance increase and the potential difference decrease. Greater the resistance, lesser the brightness. Lesser the potential difference, lesser the brightness. That's how the brightness varies. Less resistance, more brightness. High potential difference, more brightness. Less brightness. Less potential difference, less brightness. Okay, that's the connection. So basically, when they ask you to compare the brightness of a bulb, when they ask you to compare the brightness of the bulb, you need to compare those two factors. Now compare them. See, if you look at the first one, directly the current can go through the bulb. Whatever the potential difference in the cell there is directly applied on the bulb. Whatever the potential difference of the cell there, directly given to the bulb. No any reduction. Directly whatever the potential difference is given, so all the current will flow there. Look at the second connection. You have a resistor in between. When you connect a resistor, what will happen to the brightness? Resistance is increasing. Resistance is increasing. Current flow will decrease. Guaranteed the brightness will decrease. So that means I can tell. A is more brighter than B. Agree with that? Previous one, A is more brighter than B. Agree with my connection? A brighter than B. A brighter than B. Why? Previously, A, no any resistor or anything. Whatever the potential difference of the cell is directly given to the bulb there. Second one, in between you have a resistor. So current comes, it reduces and only go. All the potential difference is not given to the bulb. So the brightness will be less. Now coming to the last one. Look at the last one. What they have done in the last one. Last one is short circuited. Remember, current will always try to flow in the easiest, closest path. Current will always try to flow in the easiest, closest path. It doesn't like to go through any obstacles. Now see, this current is coming, it is meeting the junction. At the junction, we have a direct wire and then a wire with a bulb. This bulb is an obstacle for the current. You all tell me, current will like to go through this bulb path or the short circuited path? Current will try to go through the bulb path or short circuit. Guaranteed through the short circuited part, because there are no any obstacle. Most of the current will go there. Maybe a little bit of current can go. If a little bit of current goes there, a small potential is only given to this bulb. Brightness will be very, 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 very low. If you want, you short circuit a certain circuit and see, once when you short circuit it, the circuit won't work because very small current will go. Maybe even this bulb won't light up because you have an easy path for the current to go. So this is called short circuiting. Once when you short circuit, all the current will go through that short circuited path. It doesn't need to go through the appliance path because appliance is an obstacle for the current. So more than going through the appliance, it will go through the short circuited path. So most of the current will go there. Only a little bit of current will go through the bulb. A small potential will be given to the bulb. Okay. So remember here, only little current is going. Little current is going, brightness is high or very low. Brightness is high or very low. Very low. So C will have the lowest brightness. Understand and do this. Don't just guess and answer this question. C will have the lowest brightness. So they're asking descending order. A will have the greatest brightness. B will have the second greatest. C will have the lowest brightness. What's the answer? First. So what if resistor short circuit? Hute, if you take a device is actually having a resistance. Now if you take bulb is a resistor. So what we have connected here is actually a resistor. So current doesn't like to go through obstacle path. It can be a bulb, it can be a resistor, it can be a device, anything. Any device you take, resistor is only the answer. So it doesn't like to go through that obstacle path. It always go through the short circuited path. Now if you remove this short circuit, then again you get this setup. So all the current will go. Brightness will increase. Once when you short circuit it, current will take the deviation and go from there. Okay. So does the two dots at the end of the wire represent the short circuit? No. Dots will represent the connection. Now you have to see short circuit there is a wire taken and connected. You take a wire and connect it between the 2 points. That is short circuit. Dot is the connection point. That line is the wire. So in the short circuit path, if there is a bulb as well, what about it? Then that is not short circuit. If there is a bulb in the short circuit path, it's not short circuit. It is parallel connection of bulb. Maybe slightly the brightness will decrease. Compared to the first one, now the brightness will slightly decrease. But brightness will be almost the same. Slightly, a small decrement will. Okay, no? Hurry. Some information regarding an element are as follows. Has several allotropic form. Lamai, when you hear the word allotropic form, only two answers should come into your mind. Carbon only first option. Second, sulfur. Only they have allotropic forms. Carbon and sulfur. Read the second sentence. One allotropic form conduct electricity. When you hear the word conduct electricity, what is that? Carbon, the sulfur. Guaranteed. What is that? Carbon or sulfur? Guaranteed carbon. Guaranteed carbon. Then your answer is answer 1, carbon. Just imagine, second sentence is telling one allotropic form is used to make gunpowder. What you answer? First sentence is as it is. Second sentence tells us one allotropic form is used to make gunpowder. That is sulfur. Remember uses of sulfur used to make gunpowder. Fungicide, if they tell used to make fungicide, that's also sulfur. Yeah, vulcanizing rubber. All those things. Question 26. Some functions of human brain are given below. Reception of sensors. Which part of the brain is responsible for the reception of sensors? Which part of the brain can detect the sensors? Shorter name will detect the sensors. What's the shorter name? Cerebrum. Cerebrum will detect the sensors. Maintain the balance of the body. Your body balance is balanced by whom? Who will help for the balancing of the cerebellum. Cerebellum. Cerebellum is important for body balancing. Controlling rate of heartbeat, rate of respiration, all are controlled by whom? Medulla oblongata. Cerebrum, reception of sensors. Cerebellum, maintaining body balance. Controlling rate of heartbeat, rate of respiration, medulla oblongata. What are they asking? Of the above, cerebellum controls what? Body balance, only B. Next question. Consider the following statement. Consider the following statement. The rate of reaction increases when the temperature increases. Of course, yes. When temperature increase, rate of reaction increase. When you heat something, its reaction rate will surely increase. Rate of reaction increases when temperature increases. Number 2, kinetic energy of reactant particle increase when the temperature increase. Yes. What is actually temperature? What's the definition of temperature? Grade 11, part 2 book, first page, last sentence. Definition of temperature. What is temperature? Mean kinetic energy possessed by the particles of a substance is temperature. The mean kinetic, the measure of the mean kinetic energy. possessed by the particles of a substance is temperature. So basically, kinetic energy of the substance is the temperature. Kinetic energy of the particles in the substance is the temperature. If the kinetic energy of the particles increase, temperature will increase. If the kinetic energy of the particles decrease, temperature decrease. That's the sentence. The kinetic energy of reactant particles increases when the temperature increases. Of course, yes. Both A and B are correct. Both A and B are correct answer. Okay. Can you repeat the definition? The measure of mean kinetic energy. The measure of mean kinetic energy possessed by the particles of a substance. Measure of mean kinetic energy possessed by the particles of a substance. Temperature. Think like this. Let's take you are making tea. Hmm? Fortunately, unfortunately, you have to make the tea. And family members are unfortunate that thing. Chai, hari, chai, chai. No, your terms are there. Chai, right? You are making chai. Hmm. When making chai, chocolate chai, hari, chocolate chai. Right? Yeah, when you are making chocolate chai, what you do first, Puta? Thank you, one and now tell me what you do first. You take the water, keep it in a mutti, and keep it in the cooker. First, you have to do that before you do anything else. You take the mutti and wash the mutti, please. Wash the mutti and keep the cooker with water. Switch on the cooker. Right? Switch on the. So initially, if you look at the water, that's the example I usually use. Initially, if you look at the water, mutti is there, water is there, your head is there on top. You're looking at the water. Water will be very calm and quiet. Water is there. But once when the water starts boiling, now tell me, is the water calm and quiet? Once when the water starts boiling, is the water still calm and no? It starts dancing up and down. Why? Because the particles' kinetic energy increases. Initially, temperature low, kinetic energy low, the water is very calm and quiet. But once when you start heating it, temperature high, kinetic energy high, particle starts dancing up and down. Just keep that in the mind. Low temperature, low kinetic energy, high temperature, high kinetic energy. Low temperature, water is calm and quiet. High temperature, water is dancing up and down. Keep that in mind. Mm. Right. Question number 28. Which of the following phenomena cannot be explained by Archimedes' principle? What cannot be explained by Archimedes' principle? What cannot be explained by Archimedes' principle? We'll go one by one. First one. A ship cruising in the sea, sinking more when entering a river. Think. Can you explain it using Archimedes' principle? Ship that is cruising in the sea, when it enters the river, it is sinking more. First thing, why it is sinking more? Why the ship is not sinking much in the sea? but sink more in the river due to what difference? See, and what difference is there? Density. See, lot of salt is there, density is high. Little amount of salt is there, density is low. So as the density is differing, there is a difference in the density, the ship is sinking. When it sinks more water is displaced out. When it is sinking less water is displaced out. If you measure the density of the water there, densities of the water will be different. So can you see Archimedes is getting connected there? See, less water is displaced out. Density of the water is high there. River, more water is displaced out. Density of the water is low there. So Archimedes get connected there. So answer 1 can be explained by Archimedes principle. You can explain it. I think we talked deeply about Archimedes principle one day. I can remember which paper. In the first paper itself we discussed. Can remember? 2023. Question 2. Now you can see the same logics are being repeated. By the time we finish about 2020 O-level paper, after that we will have nothing to discuss. Most of the logics theories will be discussed and over. After that, what you need to do is satta you have to do the papers and go. Question 2. A balloon filled with helium gas moving upward through the air. Remember, Archimedes principle is not only defined for liquids. It is even defined for the gas. When you take a gas, when you take helium, helium's density is less than the density of air. As the helium's density is less than the density of air, helium can be displaced up. It goes up. So they are also Archimedes get connected. So this can be explained by Archimedes. Floating of sunk orange seeds in a glass of orange juice when dissolving sugar. Have you all done this? Have you all made the chai? No? Chai done. Now let's say you are making orange juice. Chai is done now. Now making orange juice. How to make orange juice? ඒක මුට්ටි keep it in the cooker. ඒව ඕනේ නෑනේ ළමයි orange juice. You take your beautiful cup. Fill some water. Squeeze the orange. Initially, orange seeds will be at the bottom. Now you will tell, no, so I will take the orange seeds and put it. But here, let's say you put the orange seed. So orange seed is at the bottom initially. Why the orange seed is at the bottom? Because density of the liquid is less than the density of the orange seed. Density of liquid less than the density of orange seed. Orange seed is more dense, it goes down. Now you put all the additional things, sugar, salt, everything you put and mix. When you put sugar, salt, everything and mix, while mixing, you would have seen these orange seeds shape come up. Orange seeds come up. Why? Once when you put the sugar, salt, all those things and mix the alamai, density of the liquid will increase. You are dissolving something, density increases. Now the density of liquid is greater than the density of orange seed. Or in other terms, orange seeds are less dense now. Liquid is more dense. Then guaranteed seeds will be on top. Remember, when you hear the connection with density, Archimedes comes there. So guaranteed, this is also Archimedes. Flotation is there. When you hear this density part, Archimedes is there. There is no density without Archimedes. Third one also can be explained by Archimedes. Lifting a large mass by hydraulic jack by applying a small force. Is this Archimedes? Hydraulic jack. Is hydraulic jack Archimedes? That is where Pascal comes. Everything we can't give to Archimedes, no. Archimedes did only the flotation part. Pascal did these things. Pascal told the connection of transmission of pressure through liquids. Hydraulic jack, hydraulic press, brake system, all those three are working according to Pascal's principle. Actually, that Pascal's principle name is not there in our textbook. What is there is principle of transmission of pressure through a liquid. That is the name given. Principle of transmission of pressure through a liquid. So this can be explained by principle of transmission of pressure through a liquid, not by Archimedes. Using Archimedes, what we can explain is the density connection. Nothing else. Whatever the pressure connections, pressure transmission connection, you can explain it using Pascal. Now we shall memorize and keep. Hydraulic jack, hydraulic press, brake system, those three can be defined by Pascal's principle. Action of a rubber sucker. There what is being applied? Action of a rubber sucker. There's no principle there, but what kind of factor is being applied there? They are atmospheric pressure. So in the same lesson, you will be learning about three things. You will be learning about Archimedes principle, Archimedes principle, Pascal's principle. Actually, this name is not there in the syllabus. What is given there is principle of transmission of pressure through liquid. This is the name there. And finally, you will be learning the applications of atmospheric pressure. I'll write it in short. ATM pressure, atmospheric pressure. All these three places, you will be learning different connection. Remember, using Archimedes principle, you can explain anything related to density and flotation. Density, flotation, displacement of a fluid. This time, Western Province paper. There was a question like this. Question number 38. Those are Western Province. Can remember. That question is Archimedes principle. So those are Archimedes. That is displacement of water. That is displacement of water direction. So those are all Archimedes. Displacement of liquid. Pascal principle. What are the places Pascal's principle is applied? Three places. Hydraulic jack, hydraulic press, brake system. Finally, we learn about applications of atmospheric pressure. What are the applications of atmospheric pressure? One, action of a rubber sucker. Action of a rubber sucker. Remove water by siphon method. Drinking water using straw. I'll just write straw and keep short form. So remember what is applied. Archimedes principle, anywhere there where you see density, flotation, displacement of liquid part, that is Archimedes. Pascal's principle of transmission of pressure through liquid, hydraulic jack, hydraulic press, brake system. Applications of atmospheric pressure, action of a rubber sucker, remove water by siphon method, straw. When I give all these things, the exam they will give the question, what principle is used in hydrometer? On. Tell me, hydrometer, what's the principle? What's the principle in hydrometer? Think what is happening in hydrometer. Flotation. You measure the density. You put it, some amount of liquid get displaced. What principle? Archimedes. So remember, hydrometer, Archimedes. It's about this density, flotation, displacement of liquid. So it's Archimedes. If you want, I'll write it 10 key. Hydrometer. Okay. So these points keep in mind. Huh. I changed it. Does anyone want me to keep that screen? Yes. Okay. Quickly write. Done. Right. So there the answer is lifting a large mass by hydraulic jack by applying a small force. That is Pascal's principle. Question 29. Question 29. The diagram shows a cross section of a cylindrical concrete ring kept on a flight of steps indicated as A, B, C, D are 4 points at which a force can be applied by a man to roll it into the upper level. What is the point at which the force can be applied on the cylinder in a suitable direction to roll it up with the lowest force? Practically think, very practically think. You have a concrete cylinder to roll up along this thing, staircase, where you can apply the smallest and the easiest force to rotate it. Where you can apply the smallest and easiest force. A. From A you apply the force. From A you apply the force. You need to apply it in upward direction like this. It will rotate. B, no, it's not easy. C, B, no. For a human, it's not easy to reach point C. D, you will feel a lot of back pain. Right? So answer is answer 1A. Actually, you can explain this in terms of moment. Why? If you take this as the point of rotation, here has the greater distance. This point has a greater distance, a perpendicular distance, a greater distance, a perpendicular greater distance. When the distance is high, turning effect will be more. So from here, turning effect is more. You can turn it easily. That way you can explain it. Huh? Last question. Last question. Question 30. Question 30. When thin iron wool is heated, it instantly burns. But though an iron nail is heated till red hot, it does not undergo considerable change. What conclusion can be drawn from this observation? Lamai, if you heat a iron nail, it won't easily burn. It will become red hot. That's it. But if you take a iron wool and heat it, it will burn. Why? If you take iron wool, lot of surface area is there. Inside everything is exposed out. Surface area is high. If you take iron nail, surface area is very low. See, only this is the only surface. This is the only surface. This, and this. But iron wool, each and every part here is a surface. So all these are surfaces. You can easily see that. So in iron wool, surface area high. Iron nail, surface area low. You all tell me, when surface area increases, what increases? What will increase? Rate of reaction will increase. Surface area decrease, rate of reaction decrease. So the question is asking, when thin iron wool is heated, it instantly burns. But though iron nail is heated until red hot, it does not undergo considerable change. What conclusion can be drawn from this observation? Iron wool act as a catalyst? No. Iron wool and iron nail undergo reaction different from each other? No, both are iron, same substance. Only the surface area is changing. The composition of iron wool and iron nail is different from each other? No, their compositions will be same, both are iron. Rate of reaction depends on the physical nature. That is correct. No? Physical nature is the surface area there. Lesser surface area, greater surface area. The physical natures are different. So rate of reaction depends on the physical nature of the reactants is a correct statement. So answer is answer 4. Okay. That's it. Today's 10 MCQs are done. And with that, we are finishing off our 110th MCQ. And stepping forward for 120th MCQ. Right? Time is going. Lot of time has gone now. From the day I started meeting you all through online session by now. Lot of time has gone. Don't waste the time now. Every time you take your phone and waste your time unnecessarily think, You can apply that time on something else that is useful. Every second you waste is the time that someone else is working for their success. Put it to the mind deeply. The time that you are wasting in your life unnecessarily, that same time someone else is fighting for the success. You can be that person. Thank you and God bless you. Meet you again on Monday.